You have lived your entire life moving in 3 dimensions. You believe that time flows forward. You believe that the solid ground beneath your feet is real. It seems like a complete picture of reality. But here's the problem. The math no longer adds up. Physics is beginning to suggest that what you call the world is just a thin, easy-to-perceive fragment of a much darker picture. The equations don't add up. We see gravity leaking out of the universe into dimensions we cannot see. We see particles reacting to events that haven't happened yet. We see silence in the stars that implies we are not explorers, but monsters. This is not science fiction. This video is about 8 specific anomalies that are causing scientists to question everything from the existence of free will to the solidity of matter itself. So, you know what the scariest number in astrophysics is? It isn't the speed of light, and it isn't the size of a black hole. It is 40 billion. Before the Kepler Space Telescope launched in 2009, we honestly didn't know if Earth was special. We thought maybe planets like ours were 1 in a trillion accidents. But Kepler stared at a tiny patch of the sky for years, and the data it sent back destroyed that idea. We now know that there are roughly 40 billion Earth-sized planets orbiting in the habitable zones of stars just in our own Milky Way galaxy. That means for every single human being alive today, there are 5 entire worlds out there capable of supporting life. But this number creates a massive problem when you look at the age of the galaxy. The Milky Way is about 13 billion years old. That is a time frame so huge that human brains can't really process it. To give you some perspective, if you compare the age of the galaxy to a 24-hour clock, human history, from the pyramids to the iPhone, has only existed for the last fraction of a second. Now, imagine a civilization that started just 15 minutes before us on that clock. That is a head start of millions of years. Even if they never figured out how to break the speed of light, physics says they should be everywhere by now. If they built ships that traveled at just 1% of light speed, mathematical models show they could colonize the entire galaxy in about 2 million years. 2 million years is nothing. It is a blink of an eye. So if there are 40 billion homes and the neighbors have had 13 billion years to move in, why is the neighborhood silent? We shouldn't just be hearing radio signals. We should be seeing traffic. We should be seeing Dyson spheres, giant shells built around stars to harvest their energy. We should be detecting the waste heat of galactic empires. But the SETI Institute has been listening for 60 years, and the WISE telescope has scanned millions of galaxies for heat signatures. The result is always the same. 0. Absolute dead silence. The most popular explanation for this is a theory called the dark forest. You've probably heard of it. It says that the universe is full of life, but everyone is hiding. It paints the cosmos as a dark room full of armed hunters. If you make a sound, you get shot. So, every smart civilization shuts up, turns off their radios, and hides in the dark to survive. It is a terrifying idea because it makes us feel like prey. It makes you want to whisper. But there is a reason why most physicists don't buy the dark forest theory. And the reason is simple. You can't cheat physics. Specifically, you can't cheat the second law of thermodynamics. Think about your laptop. When it works hard, it gets hot. You can't stop that heat. You have to vent it out with a fan, or the chip melts. A civilization is just a giant machine. If they are building spaceships, running supercomputers, or keeping billions of citizens alive, they are generating massive amounts of heat. You can hide a radio signal. You can paint your ships black, but you cannot hide entropy. That heat has to go somewhere. It radiates out into space in the infrared spectrum. To an infrared telescope, a hiding civilization would glow like a bonfire in the middle of a frozen lake. It would be the brightest thing in the sky. We have looked for that glow. We have mapped the entire sky in infrared. And we haven't found a single bonfire. This implies something much worse than a forest full of hunters. It implies that the silence isn't a strategy, it's a fact. The reason nobody is talking is that nobody is there. The galaxy is an empty house with 40 billion open doors. But if the house is empty, and we are the first ones to walk in, what does that make us? Are we just lucky? Or is there a physical law that prevents anyone else from existing at the same time as us? This brings us to a new model that suggests our loneliness isn't an accident. It's a requirement for our survival. If the galaxy is empty, it leaves us with a weird question. Why? Did everyone die? Or did they never start? To answer this, we have to stop thinking about aliens like they are characters in a Spielberg movie. We need to stop imagining green men with politics and morals, and start treating civilization as a raw physical force like gravity or fire. This is exactly what Robin Hanson, a researcher at George Mason University, did. He built a simulation that strips away all the sci-fi romance and leaves only the cold statistics. He calls it the Grabby Aliens model. The logic is brutally simple. In the universe, there are probably two types of civilizations. First, you have the quiet ones. Maybe they are like the whales in our oceans, smart, peaceful, but they never build spaceships. They stay on their home planet, they live their lives, and eventually, their star burns out and they die. From a cosmic perspective, these guys don't matter. They don't change the structure of the universe. They are invisible. But then you have the grabby ones. These are the civilizations that don't just survive, they expand. They are hungry. They look at a star and see a battery waiting to be plugged in. They look at an asteroid and see building materials. Once they figure out interstellar travel, they don't just visit other systems, they occupy them. They set up colonies, build more ships, and move to the next star. Hansen realized that this process behaves exactly like mold growing on a piece of bread. Imagine you leave a slice of bread on the counter for a week. At first, nothing happens. Then, a few tiny green spots appear. These are the first grabby civilizations waking up. These spots start small, but they grow outward in every direction. They create expanding spheres of control. Inside these spheres, everything is changed. Planets are terraformed. Stars are encased in Dyson swarms to harvest energy. The wild universe is paved over and turned into infrastructure. And here is the scary part about the math. This growth is exponential. If a civilization can travel at just a fraction of the speed of light, their sphere gets huge, very, very fast. If there were even one grabby civilization that started a few billion years ago in our corner of the universe, their sphere would have hit us by now. We wouldn't be looking at a night sky full of stars. We would be looking at the bottom of their hull. We would be part of their mining operation. The fact that we see a pristine, untouched universe tells us something crucial about our location. It means we are not inside anyone else's bubble yet. The mold hasn't reached our corner of the bread. But this brings up an even stranger problem. If the universe is billions of years old, and nobody has claimed this space yet, does that mean we are just incredibly lucky? Or is there a reason why we are sitting here in the silence? To solve that, you have to look at the clock on the wall. Because according to the timeline of the universe, you shouldn't be here. You are remarkably, suspiciously early. This is the piece of the puzzle that keeps astronomers up at night. We assume that we are living at a normal, average time in the history of the universe. But if you look at the data on how stars work, that assumption falls apart completely. The universe is 13.8 billion years old. That sounds old to us, but for the cosmos, it is basically toddlerhood. The most common type of star in the universe isn't a bright yellow sun like ours. It is a red dwarf. These are small, dim stars that burn their fuel incredibly slowly. A red dwarf can keep shining for trillions of years. This means that 99.9% of the habitable lifespan of the universe hasn't happened yet. The party has barely started. If you were a soul waiting to be born into a random civilization in cosmic history, statistically, you should have been born 100 billion years from now, orbiting a red dwarf, in a galaxy that has had eons to mature. But you weren't. You are here right now, in the very first 8% of habitable time. We have arrived at the crack of dawn before the universe has even had its morning coffee. Why? Why are we living in the cosmic dawn instead of the long, stable afternoon? Under the standard model of physics, this is a massive statistical anomaly. It is like winning the lottery on your first try. But under Robin Hansen's Grabby Aliens model, this anomaly becomes a strict requirement. Think about the bubbles of mold again. As time goes on, those bubbles get bigger. Eventually, they are going to touch. They will fill up the entire volume of the universe. Once that happens, the era of independent evolution is over. If a new life form tries to evolve on a planet 5 billion years from now, they won't have a chance. They will wake up in a universe that is already owned. They will be like bacteria trying to grow in a petri dish that is already full of penicillin. This implies that there is a deadline. Grabby civilizations like us can only emerge early. We have to exist now because later is forbidden. If we waited for the average time, there would be no free land left to evolve on. So, our existence in this specific early time slot isn't luck. It is evidence. We are observing the universe in the brief, narrow window between the cooling of the first stars and the saturation of the great empires. We are seeing the wild cosmos because we are the ones who got here before the pavement was laid down. And if you follow this logic to its final conclusion, it flips the script on everything we thought we knew about aliens. So, if we are the firstborn, how exactly do we destroy the potential of the galaxy? We don't need a Death Star. We just need a math equation that was solved in the 1940s by the physicist John von Neumann. He proposed the idea of a self-replicating probe. Imagine a machine sent to a nearby asteroid. It mines the raw materials, builds a copy of itself, and sends that copy to the next star. 1 becomes 2. 2 become 4. It is a virus made of metal. If we launched just one of these probes today, and it traveled at only 10% of the speed of light, the math of exponential growth says it would consume every asteroid and planet in the Milky Way in less than 4 million years. Think about that time frame. 4 million years is nothing. The dinosaurs vanished 65 million years ago. We could have paved the entire galaxy 15 times over since the T-Rex died. The only reason we haven't done it yet is that we just figured out how to build rockets. But once we start, we become the Great Filter. We usually think of the Great Filter as a disaster that kills civilizations, like nuclear war or a plague. But in this model, we are the filter. Our expansion acts like a sterilization wave. Every star system our machines reach becomes occupied territory. The energy is harvested. The resources are stripped. If life tries to evolve on a planet in that system a billion years from now, it won't be able to. It will wake up in a universe that has already been eaten. This means we are not explorers. We are a cosmic pathogen. We are programmed by evolution to consume and expand, and we have no off switch. We are the reason the future of the galaxy will be silent. But if our role in the physical universe is just to be a mindless, consuming machine, what does that say about the mind driving the machine? Is there anything real inside us, or is our consciousness just another trick of the code? So, if we are the monsters on the outside, what is driving the bus on the inside? To find out, you just need to pinch your arm. Seriously do it. You feel pain, right? That feeling, that sharp, unpleasant sensation, is the biggest problem in the known universe. It is called the hard problem of consciousness, and it has broken the brains of the smartest people on Earth for 300 years. Here is why it doesn't make sense. Science is built on materialism. We believe that the universe is basically a giant Lego set made of dead atoms. We assume that if you take enough carbon and water and stack them in a complex pile called a neuron, eventually the pile will wake up and say, hello. But think about how insane that sounds. A rock doesn't feel pain. A toaster doesn't feel sad when it burns the bread. A supercomputer can beat you at chess, but it doesn't enjoy winning. It's just processing math. So how do you get sadness or joy out of a pile of dead sodium and potassium? You can map the brain perfectly. We can see the electrical signal travel from your arm to your cortex. But nowhere on that map is the feeling of pain. The atoms are just atoms. The electricity is just electricity. There is no magic slot where the experience happens. David Chalmers, a famous philosopher, pointed out that you could theoretically build a zombie, a robot that looks like you, screams when you hit it, and tells jokes. But inside, there is nobody home. It's dark. According to the laws of physics, that zombie should be all that exists. There is no physical reason for the lights to be on inside your head. But the lights are on. You are hearing my voice right now. You are judging these words. And that simple fact, that you exist as an observer, destroys the standard model of physics. It implies that matter doesn't create the mind. It implies that we have the whole equation backwards. So, if the brain isn't generating the mind, where is the signal coming from? If you eliminate the impossible, whatever is left must be the truth, no matter how crazy it sounds. And the alternative to materialism is a theory that flips reality inside out. It is called Analytic idealism, and recently, a computer scientist named Bernardo Kastrup has been using it to scare the hell out of the scientific community. The theory asks a simple question: what if the universe isn't a box of rocks? What if the universe is a mind? Think about when you dream. Tonight, when you go to sleep, your brain will create a world. You will see a fire, and it will look bright. You will touch a wall, and it will feel solid. If a dream monster chases you, your heart will race. But is the wall real? No. Are there atoms in the fire? No. The entire world is made of thought. Your mind is generating the physics, the color, and the solidity in real time. To the character in the dream, the world feels physical, but the stuff underneath it is just consciousness. Kastrup argues that real life works exactly the same way. The universe is one single, infinite consciousness. Everything we see, the stars, the planets, the coffee cup on your table, are just ripples in that cosmic mind. Matter is just the image that the mind presents to us. This fixes the hard problem instantly. We don't have to figure out how dead atoms create feelings, because there are no dead atoms. There is only feeling. The universe feels the gravity of a black hole the same way you feel a heavy mood. But if this is true, it creates a massive, terrifying paradox. If the universe is just one big mind, why am I not you? Why are my thoughts private? Why can't I hear what the guy in China is thinking right now? If we are all God, why do we feel so small, separate, and alone? To answer that, Kastrup didn't look at a telescope. He looked at a psychiatric ward. He found a mechanism that explains exactly how one mind can break into a billion pieces. It is called dissociative identity disorder, or DID. We used to call it multiple personality disorder. It happens when a human mind faces trauma it can't handle. To survive, the mind fractures. It builds walls. It creates alters, separate personalities that share the same brain, but have no idea the others exist. Here is the creepy part. This separation is physically real. Doctors have documented cases where one personality is blind. Their eyes work fine. The brain is healthy. But when that personality is in charge, the brain physically blocks the signal from the optic nerve. The mind creates a biological filter to keep the illusion of separation alive. The theory suggests that this is exactly what happened to the universe. The Big Bang wasn't an explosion of gas. It was a psychotic break. The cosmic mind dissociated. It shattered into trillions of tiny alters. You, me, the dog, the bacteria. We are not independent souls. We are the symptoms of a cosmic mental illness. The boundary that you call yourself, the thing that separates your skin from the air, is just a dissociative wall. It is a filter created by the universe to forget that it is alone. We are the schizophrenia of God. And you know what the scariest proof is? Quantum mechanics actually sees the cracks in the wall. Look at entanglement. If you separate two particles by 1 billion miles and touch one, the other reacts instantly, faster than light. Einstein hated this. He called it spooky, because in a physical world of separate objects, that is impossible. You can't send a signal faster than light. But in a mental world, it makes perfect sense. Think about your own thoughts. Do you have to travel a distance to switch your focus from a memory of London to a memory of Paris? No. They are both in your mind. They are instantly connected. Entanglement proves that the distance between us is an illusion. The universe is still one, but we are designed not to see it. This leads to a horrific realization about death. We spend our whole lives protecting ourselves. We are terrified of dying. But if your personality is just a symptom of dissociation, then death isn't the end. Death is the cure. It is the moment the wall comes down and you dissolve back into the madness of the infinite mind. So, we have questioned our timeline and we have questioned our own minds, but at least we can trust the ground beneath our feet, right? We can trust that the physical universe out there is stable, random, and fair. That is what they teach you in school. It is called the cosmological principle. It states that the universe is uniform. It means that no matter where you look, left, right, up, or down, the cosmos looks basically the same. There are no special places. There are no edges. It is just a smooth, endless sea of galaxies expanding evenly in all directions. It is a comforting idea because it implies that space is safe and predictable. But there is a problem. When we actually took a picture of the universe, it didn't look smooth at all. It looked like it had been beaten up. I am talking about the cosmic microwave background, or CMB. This is the oldest light in existence, the afterglow of the Big Bang itself. In 2013, the Planck satellite gave us the most detailed map of this light ever made. According to the standard model, this map should look like static noise, random speckles of hot and cold, distributed evenly like sand on a beach. But when astronomers looked at the southern hemisphere of the sky, they saw something that made them check their instruments for dirt. They saw a massive, deep blue hole. It is called the CMB cold spot. It is a region of space about 1 billion light years across that is significantly colder than everything around it. It shouldn't be there. Statistically, the chance of a spot that big appearing by random luck is almost zero. It is like looking at a calm ocean and seeing a giant frozen whirlpool that refuses to move. Scientists tried to explain it away. They said it was a supervoid, just a big empty space with fewer galaxies. But when they counted the galaxies in that direction, the void wasn't empty enough to explain the temperature drop. The math didn't add up. So, what is it? Some physicists, like Laura Massini-Houghton, have suggested that it isn't a void at all. It is a bruise. They calculate that this spot is exactly what it would look like if our universe had collided with another universe in the distant past. Imagine two soap bubbles bumping into each other. The point of contact leaves a dent. If that is true, the cold spot is the first physical evidence that we are not alone in the multiverse. We have a neighbor, and billions of years ago, we crashed into them. But if we survived that crash, are we safe now? Or is the damage from that collision doing something to us right now that we can't stop? If the cold spot was just a scar from the past, maybe we could ignore it. But it turns out, the damage isn't static. It is moving, and it is taking us with it. You probably know that the universe is expanding. Galaxies are supposed to be drifting apart from each other like dots on a balloon that is being inflated. In this model, everything moves away from everything else at a predictable speed. There shouldn't be any traffic jams or rivers in space. But in 2008, a team led by Alexander Kashlinsky at NASA found something that broke the model. They looked at the motion of huge galaxy clusters, groups of thousands of galaxies bound together by gravity. They expected to see them expanding randomly. Instead, they saw a river. They found that millions of galaxies, including our own Milky Way, are not just expanding. They are drifting. They are all moving in the same specific direction, towards a patch of sky between the constellations of Centaurus and Hydra. And they are moving fast. The speed is shocking. About 600 kilometers per second. That is 2 million miles per hour. They call this the dark flow. Think about what that implies. It is like you're swimming in a calm ocean, and suddenly you realize that you and every other swimmer for 1,000 miles are being pulled by a silent, invisible current in one direction. The scariest part? The force required to pull that much mass is impossible. All the visible matter in the known universe isn't heavy enough to generate that kind of gravity. You could stack every star we can see into a pile, and it wouldn't be strong enough to drag these galaxies at that speed. So, what is pulling us? Kashlinsky's team suggested that the source of the gravity lies outside the visible universe. Something beyond the edge of our map is reeling us in. We are being dragged by a monster that is too far away to see, but massive enough to tilt the entire cosmos. And the closer we look at the destination, the darker it gets. We usually assume that because we have telescopes, we can see everything. But there is a huge blind spot in our vision called the zone of avoidance. It is the thick band of dust and stars from our own Milky Way galaxy that blocks our view of the deep universe behind it. Unfortunately for us, the dark flow is dragging us straight towards that blind spot. We are flying blind into the mouth of the unknown, but thanks to radio telescopes that can punch through the dust, we have started to map the heavyweights waiting for us in the dark. First, we found the Great Attractor. It is a gravitational anomaly about 200 million light years away. It is pulling our galaxy and thousands of others towards it. For years, we thought this was the monster. But when we finally got a better look, we realized the Great Attractor wasn't big enough to explain the speed of the flow. It was just a crumb. So we looked further behind it, and we found the Shapley supercluster. This is the single largest concentration of galaxies in the nearby universe. It is a titan, containing the mass of 10,000 Milky Ways. It is a city of stars so big it warps space-time like a bowling ball on a trampoline. But here is the horror story. Even the Shapley supercluster isn't big enough. The math says that even its gravity accounts for only a fraction of the dark flow. The real source, the true Leviathan, is still further out, past the horizon, hidden in the unobservable universe. Physicists call this the tilt theory. They suggest that our entire observable universe is just a small patch on a slope, and we are sliding downhill. We are falling into a gravitational drain created by a structure so colossal that our entire reality is just a speck of dust orbiting it. We will never see it. The light from it will never reach us because the space between us is expanding too fast. We are like ants on a leaf flowing down a river, unaware that a waterfall is coming. We just know that the current is getting faster. But if we are falling into a gravity well of infinite depth, what happens to matter when it hits the bottom? We know what happens in black holes. Things get crushed. But information? Information gets weird. And this leads to a theory that suggests our three-dimensional world, this room, your body, the depth of the sky, might be the biggest optical illusion of all. To understand why the universe might be an illusion, we have to talk about trash. Specifically, what happens when you throw something away. If you take a book, say the complete works of Shakespeare, and burn it, you think the information in that book is gone. But in physics, that is not true. If you were smart enough, you could collect every chaotic molecule of ash, every photon of light, and every wisp of smoke. If you had a powerful enough computer, you could reverse the laws of physics and reconstruct the book perfectly. This is a fundamental rule of quantum mechanics called unitarity. It says that information is never lost. The past is always preserved in the present state of the particles. But in the 1970s, Stephen Hawking found the one place where this rule goes to die. Black holes. Hawking realized that black holes are not perfectly black. They radiate energy, now called Hawking radiation, and slowly evaporate over trillions of years. Eventually, the black hole disappears completely. But here is the problem. The radiation is random. It contains no data about what the black hole ate. So if you throw that Shakespeare book into a black hole and wait for the hole to evaporate, the book is gone. The information is deleted from the universe. This seems like a technicality, but it is a catastrophe for physics. If information can be destroyed, then we cannot trust the laws of cause and effect. It means the past is not real. It means history can be erased. This triggered a 40-year war in the physics community. On one side, you had Stephen Hawking saying, "The information is gone, deal with it." On the other side, you had Leonard Susskind saying, "If the information is gone, all of physics is wrong." They needed a solution that saved the information without breaking the black hole. And the solution they found is so radical that it changes the definition of place entirely. Susskind and his colleague Gerard at Hooft realized that we were looking at the black hole wrong. We assumed that when the book falls in, it goes inside the sphere. We assumed that the information is held in the three-dimensional volume of the whole. But what if volume is a lie? They proposed that when an object hits the event horizon, the point of no return, it doesn't just pass through. From the perspective of an outside observer, the information gets scrambled and plastered onto the surface of the horizon. Think of a can of soup. The soup is the three-dimensional stuff inside, but the label is a two-dimensional sheet wrapped around the outside that tells you exactly what is in the soup. Susskind argued that a black hole is exactly like that can. All the information about the star, the light, and the books that fell in is stored on the two-dimensional surface of the event horizon. It is encoded like a complex barcode. This saves physics. The information isn't destroyed, it is just reformatted. It turns from a 3D object into a 2D code. But if you follow this logic, it implies something terrifying about the nature of space itself. If all the information required to describe a three-dimensional object can be stored on a two-dimensional surface, then the third dimension is technically unnecessary. It is redundant. The volume, the inside of the black hole, is just a projection of the data on the surface. It is a hologram. And if a black hole is a hologram, what prevents the rest of the universe from being one too? This is where the floor drops out from under you. Look around the room you're sitting in. You see depth. You can walk forward and backward. You feel like you're occupying a solid, three-dimensional volume of space. Your brain tells you that volume is the fundamental container of reality. But in 1997, a physicist named Juan Maldacena proved that you can mathematically describe a complex, three-dimensional universe perfectly using only equations that exist on a flat, two-dimensional boundary. It is called the ADAS-CFT correspondence. It showed that the bulk, the empty space we think we live in, is mathematically identical to the boundary, the flat shell surrounding it. Think about what that means for you. We are currently sitting inside the observable universe. It has a boundary, the cosmological horizon, about 46 billion light-years away. If the holographic principle holds true, then everything inside this sphere, the stars, the galaxies, and you, is just a projection. The real you is not sitting in a chair. The real you is a chaotic smear of data encoded on the furthest edge of the universe. You are flat. You are two-dimensional information that is being projected inward to create the illusion of depth. We even have physical evidence that hints this might be true. It is called the Bekenstein bound. It turns out you cannot pack infinite information into a region of space. There is a limit, like the resolution of a screen. If space were truly continuous and three-dimensional, you could zoom in forever. But you can't. You hit a pixel limit called the Planck length. The universe is pixelated, and the number of pixels corresponds to the surface area, not the volume. This is the hallmark of a hologram. You are living in a video game where the screen wraps around the sky. But if we are just code running on the edge of space, what happens when the computer starts to run out of power? Because code is eternal, but the machine is not. If the universe is a hologram projected from the edge, it faces a critical limit that has nothing to do with code and everything to do with energy. Every simulation, every computer, and every living thing needs a battery to run. And the terrifying reality of our cosmos is that the battery is dying, and there is absolutely no way to recharge it. You might think that physics is full of unbreakable laws, but that is actually not true. Most laws of physics are reversible. You can play the tape of a planet orbiting a star backwards, and the math works perfectly. You can crash two atoms together, and the movie makes sense in reverse. But there is one law, just one, that has a direction. It is the dictator of our reality, the second law of thermodynamics. It states simply that entropy, which is a measure of disorder and useless energy, always increases. Things break, but they never unbreak. Coffee cools down, but it never spontaneously heats up. You age, but you never get younger. This isn't just a quirk of nature, it is the fundamental tax we pay for existing. Every time you think a thought, every time a star fuses hydrogen, the total amount of useful energy in the universe drops, and the total amount of chaos rises. This flow from order to disorder is the only reason you perceive time at all. Have you ever asked yourself why you can remember the past but not the future? It is because the past had lower entropy. The arrow of time isn't a timeline, it is a slide. We are sliding down a hill of energy, moving from a complex, organized Big Bang towards a state of total, flat randomness. We are currently living in the Goldilocks phase of this slide. We are catching the energy as it falls. We build cities, we write songs, we create complex biological structures. But we are only able to do this because we are increasing the entropy of our surroundings to pay for it. Life is basically an entropy machine. We eat ordered food and excrete disordered heat. But the problem with a slide is that eventually, you hit the ground. The universe is expanding, the fuel is burning, and the clock is ticking. What happens when the fuel runs out? What happens when the universe reaches the bottom of the hill and there is no more energy to push the arrow of time forward? To understand how short our time in the sun really is, we have to look at the timeline of the future. Right now, we are living in what astrophysicists call the stelliferous era, the age of stars. It is bright, it is warm, and it feels like it will last forever. But if you map the lifespan of the universe, this era is just a camera flash in a dark room. In about 100 trillion years, the last star will die. The red dwarfs will burn through their hydrogen and fade into white dwarfs. The massive stars will explode and collapse into black holes. And then, the lights go out. Permanently. The universe will enter the Degenerate era. It will be a graveyard filled with the cooling corpses of stars and drifting black holes. But even the corpses won't last. Grand unified theories of physics suggest that the proton, the fundamental building block of every atom in your body, the chair, and the planet, is not stable. It has a half-life. If these theories are correct, then roughly 10 to the power of 34 years from now, the matter itself will begin to dissolve. The white dwarfs will turn into dust. The planets will evaporate into radiation. Your body, your house, and the Earth will simply unspool into a thin soup of subatomic particles. Eventually, the only things left will be the black holes. They will be the kings of the void for an unimaginable expanse of time. Years numbered by a 1 followed by 100 zeros. They will eat the remaining dust and drift in the silence. But even they are not immortal. As we discussed with the holographic principle, black holes leak. They radiate Hawking radiation. Slowly, over eons that make the current age of the universe look like a nanosecond, the black holes will shrink and explode. And when the last black hole pops, the universe will be truly empty. There will be no matter, no light, no gravity, just a vast, expanding void filled with a few lonely photons cooling down towards absolute zero. This is the heat death. But the freezing cold isn't the worst part. The worst part is what happens to the concept of existence itself. We usually imagine the heat death as a lonely place. We picture ourselves floating in the dark, bored, waiting for something to happen. But that imagination makes a fatal error. It assumes that you can still wait. It assumes that time still exists. But time is not a physical object. You cannot hold a jar of time. In physics, time is a measurement of change. We define a second by the vibration of a cesium atom. We define a year by the motion of the Earth. Time requires events. It requires energy flowing from state A to state B. But in the heat death, the universe reaches maximum entropy. The temperature is exactly the same everywhere. The energy is perfectly distributed. There is no state A and state B anymore. Everything is state A. This means that no event can ever happen again. No particle can move, because moving requires an energy difference. No thought can form, because a thought is a chemical reaction. No clock can tick. When the universe hits this bottom, the arrow of time breaks. The movie doesn't just fade to black. The reel jams. The universe enters a state of eternal, frozen now. It is not death, because death implies an end. This is a stasis. It is an eternity of static. If you were somehow present at the end of time, you wouldn't experience darkness. You wouldn't experience anything. You would be trapped in a single, unchanging instant forever. It is the ultimate prison, a cage with no bars, built out of pure equilibrium. But here is the question that drives physicists crazy. Is this really the end? Because if time is infinite and quantum mechanics is random, then impossible things can happen given enough time. Is it possible that in the middle of this dead, frozen eternity, the ashes could spontaneously wake up? Could the dead universe dream itself back into existence? So, the universe is dead. The energy is gone. The clock has stopped. This should be the end of the story. But in 2012, a Nobel Prize-winning physicist named Frank Wilczek asked a question that broke the rules of the game. He asked, "Can something move forever without using any energy?" Your intuition screams, no. We all know that perpetual motion machines are impossible. If you spin a top, friction kills it. If a planet orbits a star, it eventually decays. Motion requires fuel. This is the basic law of the playground. But Wilczek found a loophole in the math of symmetry. He realized that just as atoms can arrange themselves into a repeating pattern in space to create a crystal, like a diamond or salt, they should theoretically be able to arrange themselves into a repeating pattern in time. He called them time crystals. It sounds like fantasy, like a magical item from a video game. But in 2017, researchers at Google and the University of Maryland actually built one. They took a chain of ions, trapped them with lasers, and hit them with a pulse. What happened next was impossible under standard thermodynamics. The ions started to flip. They moved in a repeating cycle, tick-tock, tick-tock. But they weren't consuming energy to do it. They were in their lowest possible energy state, the ground state. Usually the ground state is motionless. It is a rock, sitting at the bottom of a hill. But a time crystal is a rock that rolls up and down the hill forever, for free. It breaks time translation symmetry. It is an object that keeps moving even after the universe has died. This means that in the freezing dark of the heat death, there will still be things moving. But don't mistake this for life. Life learns, life changes. A time crystal just repeats. It is a zombie state of matter. It is a heartbeat without a body, ticking away in the silence for eternity, measuring a time that no longer has any meaning. But if matter can get stuck in a loop, what about information? What about us? If you have an infinite amount of time and a limited number of atoms, eventually the shuffling of the cosmic deck forces the scariest thing of all to happen: the return of the ghosts. This brings us to the nightmare of Poincaré recurrence. The mathematician Henri Poincaré proved that if you have a closed system with a finite number of particles and you wait long enough, the particles will eventually return to their original starting position. Think of it like shuffling a deck of cards. There are a lot of combinations. An 8, followed by 67 zeros. But if you shuffle the deck forever, eventually, you will repeat the exact same order. You will deal the same hand twice. The universe is just a very big deck of cards made of atoms. In the heat death, those atoms are drifting randomly in the dark. But they are moving. They bump into each other. They fluctuate. Most of the time, they just form random noise. But if you wait 10 to the power of 10 to the power of 50 years, the atoms will randomly bump together to form a shape. Maybe a rock. Maybe a toaster. And statistically, eventually, they will bump together to form a human brain. Physicists call this a Boltzmann brain. It is a fully formed, conscious mind that spontaneously hallucinates into existence out of the void. Here is the horror. That brain comes preloaded with memories. It remembers a childhood. It remembers eating breakfast. It remembers clicking on this video. It thinks it is a person living in the 21st century. But none of it is real. The memories are just a random arrangement of neurons created by chance in the dead universe. The brain exists for a few seconds, thinks a few thoughts, and then dissolves back into the vacuum. But here's the question that should make you sweat. How do you know you aren't one of them right now? The math says that in an infinite future, there will be trillions more Boltzmann brains than real human brains. Statistically, it is vastly more likely that you are a hallucinating brain floating in the heat death right now than a real biological human with a past. Your entire life, your family, this screen, it could all be a fleeting fever dream of a dying cosmos. Can you prove it isn't? So, we are trapped. We are either heading for a frozen eternity, or we are hallucinations in a graveyard. It feels like a prison sentence. But all of this assumes one thing, that time only moves in one direction. We assume that the past causes the future. You drop a glass, and it breaks. The breaking future is caused by the drop, past. But what if I told you that this rule doesn't actually exist in the blueprints? If you zoom into the atomic level, the arrow of time vanishes. Look at the fundamental equations of physics. Schrödinger's equation for quantum mechanics, or Maxwell's equations for light. They are time symmetric. This means they work exactly the same way if you swap t for minus t. If you recorded a video of two electrons colliding and bouncing off each other, and then you played that video backward, it would look perfectly normal. A physicist watching it wouldn't be able to tell which version was real. To an atom, past and future are just directions, like left and right. So if the building blocks of reality don't care about time, why are we so obsessed with it? Why do we feel like we are being dragged forward? For a long time, we thought this was just a quirk of entropy, but recent experiments suggest something much wilder. They suggest that the symmetry isn't broken. They suggest that the future is just as real as the past, and it is pushing back. Imagine you are walking through a crowd. You push people out of the way, past affecting future. But people are also pushing you back, future affecting past. There is a theory called Retrocausality, which argues that your decisions right now are not just based on what happened to you yesterday. They are being influenced by what will happen to you tomorrow. It implies that the end of time isn't a destination we are waiting for. It is an anchor that is already there, pulling us toward it. And we have an experiment that proves this insanity is real. You might think that time travel is impossible. You might be certain that the past is locked in stone and the future is a blank page waiting to be written. But there is an experiment that physicists have been performing since 1999 that proves your intuition is dead wrong. It is called the Delayed Choice Quantum Eraser. To understand why this experiment is so disturbing, you have to look at the setup. It is a modification of the famous double slit test. When you fire photons at a wall with two slits, they usually act like waves. They pass through both slits at once and create an interference pattern on the screen behind them. But if you try to measure which slit they go through, they panic. They stop acting like waves and start acting like solid particles. The interference pattern disappears. This collapse is weird, but it is standard quantum mechanics. The eraser version adds a twist that breaks the timeline. In this experiment, the scientists fire the photon, let it pass through the slits, and let it hit the screen. The journey is over. The photon has landed. A mark is recorded on the wall. Then, after the impact has already happened, the scientists make a random choice. They either keep the information about which slit the photon went through, or they erase it. Common sense says this choice shouldn't matter. The photon is already dead. Its path is history. But the data shows the impossible. If the scientists decide to erase the information after the photon hits the screen, the record on the screen shows an interference pattern. If they decide to keep the info, the record shows a particle pattern. Think about the implications of that sequence. The photon had to decide whether to be a wave or a particle before it hit the screen. But the decision that determined its behavior wasn't made until after it hit the screen. It implies that the particle somehow knew what the scientist was going to do in the future. The arrow of causality was pointing backwards. The future event, the choice, rewrote the past event, the path. This isn't a theory or a math trick. It is a repeatable physical fact. It suggests that the timeline isn't a straight line where cause leads to effect. It suggests that A and B are talking to each other across the gap. So, if a subatomic particle can adjust its behavior based on an event that hasn't happened yet, are the atoms in your brain doing the same thing? If the future can change the past, we have to throw out our entire model of reality. We can't use the river of time metaphor anymore because rivers don't flow uphill. We need a model that flows both ways. In the 1940s, two legends of physics, John Wheeler and Richard Feynman, proposed exactly that. It is called the absorber theory. They looked at the fundamental equations of electromagnetism and noticed a ghost in the math. When an electron shakes, it emits light. Mathematically, this emission produces two distinct waves. One wave travels forward in time. This is the retarded wave that we see. But the equation also produces a second wave that travels backward in time, the advanced wave. Most physicists just crossed out the backward wave. They said, that doesn't make sense. Let's pretend it is zero. But Wheeler and Feynman asked, what if it isn't zero? They argued that every time you see a light bulb, you're witnessing a handshake across time. The electron in the bulb sends a wave forward to your eye. But the electron in your eye, at the precise moment it receives the signal, sends a confirmation wave backward through time to the bulb. The present moment, the reality you're experiencing right now, is just the interference pattern where these two waves crash into each other. This theory implies that the future isn't a void waiting to be filled. It is a solid, physical continent that is constantly broadcasting signals back to us. The year 3000 is just as real as the year 2000. It is sitting there on the timeline, sending advanced waves back toward us, shaping the events of today. It means the universe is solving a puzzle from both ends at once. The Big Bang pushed forward, and the end of time is pushing back, and you are stuck in the middle. But if the future is already solid enough to send waves back to the present, what does that mean for your ability to choose your own path? This brings us to the most claustrophobic realization in physics. We love the idea of free will. You like to believe that you can choose to close this video or keep watching, and that the outcome depends entirely on you. You feel like the author of your own story. But if the eraser experiment and the Wheeler-Feynman theory are correct, you are not the author. You are the character. If the future can influence the past, then the future must already exist. You cannot send a signal from a place that isn't there. This leads to the concept of the block universe. Imagine a movie stored on a DVD. The opening scene and the credits exist at the same time on the plastic disc. The characters inside the movie don't know the ending, but the disc does. In a retrocausal universe, your life is that disc. You feel like you are making decisions, but you are actually just fulfilling a boundary condition. The state of the universe a billion years from now is dictating the path of the atoms in your brain right now. When you decide to eat a sandwich, You aren't making a choice. You are balancing a mathematical equation that connects the Big Bang to the heat death. The you of tomorrow is pulling the strings of the you of today. This destroys the concept of agency. It means you are a puppet, but you're a strange kind of puppet that is programmed to feel like it is free. The strings are invisible, woven out of time-symmetric waves, but they are there. Does that make you feel trapped? It should. It means that every mistake you ever made was necessary. Every tragedy in history was written in the code before the Earth was formed. The script is finished. We are just playing it out. But if the script is finished, who wrote it? And if the story has a defined beginning and end, does it just stop? Or does the DVD simply restart from the beginning? This brings us to the structure of the cosmic loop and the possibility that we are living in a graveyard of previous universes. If the script of the universe is already written, we have to ask, who pressed play? And more importantly, was this the first time they watched the movie? In school, we are taught the standard story. We are told that 13.8 billion years ago, there was a singularity. Then, there was a Big Bang. Space and time were created out of nothing, and they have been expanding ever since. In this story, the Big Bang is the starting line. Before that moment, there was no before. But Sir Roger Penrose, one of the most respected mathematical physicists in history and a Nobel Prize winner, thinks this story is wrong. He argues that the Big Bang was not the beginning. It was just a bridge. His theory is called Conformal Cyclic Cosmology, or CCC. It solves a problem that most physicists try to ignore: the uncanny similarity between the beginning of the universe and the end. Think about it. At the Big Bang, the universe was incredibly hot, dense, and full of energy, but particles were moving so fast that mass didn't really matter. It was a soup of pure radiation. Now, fast forward to the heat death. The universe is cold, empty, and full of radiation again. Penrose realized that mathematically, a universe full of pure radiation loses track of scale. If you don't have solid objects like clocks or rulers, big and small lose their meaning. A universe that is infinitely big and empty looks mathematically identical to a universe that is infinitely small and dense. Penrose suggests that when our universe finally dies and reaches maximum entropy, it forgets how big it is. In that moment of mathematical confusion, the infinite cold of the future snaps into the infinite heat of a new Big Bang. This means that our Big Bang was actually the heat death of a previous universe. We call that previous universe an aeon. And when our universe dies trillion of years from now, our death will become the Big Bang for the next aeon. It is a beautiful, terrifying idea. It implies that we are not living in the universe. We are living in universe number X in an infinite chain of universes. But usually, theories like this are just math games. You can't prove what happened before the Big Bang because the explosion should have erased all the evidence. Or so we thought. Penrose claims that the ghosts of the past actually survived the fire. If a previous universe existed, surely it was wiped clean by the cataclysm of the Big Bang. You can't burn a house down and expect to find the furniture still standing. But Penrose argues that while matter gets destroyed, gravity does not. Gravitational waves are ripples in the fabric of space-time itself, and they can pass through the transition from one aeon to the next. To prove this, Penrose and his team took the data from the WMAP and Planck satellites, the same maps of the cosmic microwave background that showed us the cold spot. They were looking for a very specific pattern. They weren't looking for random noise, they were looking for concentric circles. In the standard model of cosmology, the temperature of the early universe should be random. There shouldn't be any geometry. But when Penrose analyzed the data, he found distinct rings where the temperature was significantly higher than the average. He called them Hawking points. These aren't just vague shapes. They are sharp, defined circles of energy imprinted on the sky. The statistical chance of these rings appearing by accident is incredibly low. Other teams have tried to debunk this, but the rings keep showing up in the data. So, we have physical scars on the face of our universe. We have rings of fire that are older than the Big Bang itself. What could possibly be powerful enough to punch a hole through the end of one universe and leave a mark on the next one? The answer brings us back to the monsters we talked about earlier. Supermassive black holes. To make a gravitational wave strong enough to survive the death of a universe, you need an event of apocalyptic power. You need a collision between black holes that weigh billions of times the mass of the Sun. Imagine the previous aeon, the universe that existed before ours. It had its own galaxies, it had its own stars, and in the centers of those galaxies, it had monster black holes. Over trillions of years, those black holes ate everything around them. Eventually, they started colliding with each other. When two supermassive black holes merge, they release an unimaginable amount of energy in the form of gravitational waves. It rings the universe like a bell. These waves ripple outwards in a perfect circle. According to Penrose, these ripples didn't stop when that universe died. They kept traveling. When that aeon collapsed and transitioned into our Big Bang, those gravitational ripples were stamped onto the new matter like a fossil in rock. So when you look at those Hawking points on the map, you're not looking at something from our world. You're looking at the gravitational ghost of a galactic collision that happened in a dead universe trillions of years ago. You're looking at the tombstone of a civilization that might have lived and died before time even began for us. This realization turns our universe into a graveyard. We are walking on the dust of the past. The atoms in your body are just recycled ash from the previous fire. And the horror is that the cycle doesn't stop with us. One day, the supermassive black hole at the center of our Milky Way will collide with the one in Andromeda. It will send out a ring of gravity. Long after Earth is gone and long after our stars burn out, that ring will keep moving. It will cross the bridge into the next Big Bang. We will become nothing more than a Hawking point on the sky of the next species. We are just a message in a bottle that nobody will ever read. But what exactly drives this endless cycle of death and rebirth? Is it automatic? Or is there a physical collision happening in a higher dimension that forces the restart? Penrose's theory tells us that the universe repeats, but it doesn't explain how. How does a dead, cold universe suddenly catch fire and start over? To find the ignition switch, we have to leave standard cosmology and enter the 11-dimensional world of M-theory. We are used to thinking of the universe as a giant bubble that contains everything there is. But M-theory suggests that our universe is actually just a thin membrane, or a brain floating in a much larger, higher dimensional space called the bulk. Think of a loaf of sliced bread. Our entire three-dimensional reality, every star, every galaxy, every atom, is trapped inside just one single slice of that bread. We can move left, right, up, and down within the slice, but we cannot move out of the slice into the rest of the loaf. We are stuck to the surface. This explains why we can't see the higher dimensions. It is like being an ant walking on a sheet of paper. To the ant, the world is flat. It has no concept of up or down off the paper. If you hovered your finger a millimeter above the ant, it wouldn't know you were there. You would be invisible because light travels along the paper, not off it. In this model, the bulk is the empty space between the slices. It is a forbidden zone that particles of matter cannot enter. Electrons, protons, and photons are open strings in string theory. Their ends are physically pinned to our brain. They can't leave. But this isolation creates a terrifying possibility. If we are just one slice in the loaf, what is on the other slices? Is the bulk empty, or is there something floating right next to us, just a fraction of an inch away in the fourth spatial dimension? If there is another brain floating next to ours, we wouldn't be able to see it. Light cannot travel through the bulk. You could be staring right at a parallel universe and see nothing but empty air. But while light is trapped, There is one force that might be able to jump the gap: gravity. According to string theory, the particle that carries gravity, the graviton, is a closed string. It is a loop. It has no loose ends to get stuck to our membrane. This means gravity is free to drift off our world and float out into the bulk. This solves one of the biggest mysteries in physics: dark matter. For decades, we have known that galaxies are spinning too fast. There is not enough visible matter to hold them together. They should fly apart. We assumed there must be some invisible ghost matter inside our own universe providing the extra gravity. But the brain theory offers a creepier explanation. What if the extra gravity isn't coming from here? What if it is leaking in from there? Imagine a shadow galaxy on the neighboring brain. It has its own stars and planets. It is massive, and it is floating directly above our Milky Way in the higher dimension. We can't see their stars, but we can feel their weight. Their gravity leaks across the gap and pulls on our stars. This means that dark matter is just the gravitational shadow of a parallel world. We are haunting each other. We are two civilizations separated by a millimeter of hyperspace, locked in a gravitational dance, completely invisible to one another. But the danger isn't that they are watching us. The danger is that the gap between the slices isn't stable. This brings us to the most violent theory of creation in physics, the Ekpyrotic universe. Proposed by Paul Steinhardt and Neil Turok, it challenges the idea that the Big Bang was a random explosion from nothing. They argue that the Big Bang was a collision. In this model, the two brains, ours and the neighbors, are not fixed in place. They drift, they ripple, and they are attracted to each other. Over billions of years, they slowly get closer and closer together, moving through the bulk. Eventually they touch. Imagine two giant metal plates slamming together. The kinetic energy of that impact has to go somewhere. It gets converted instantly into intense heat and radiation. To an observer inside the brain, it looks like the entire universe suddenly caught fire. The temperature spikes to trillions of degrees. Matter is vaporized and reformed. Space expands rapidly from the shockwave. We look at that event and call it the Big Bang, but it wasn't a beginning. It was just a clap of thunder. After the crash, the brains bounce off each other and drift apart. The universe cools down. Galaxies form. Life evolves. We live our lives in the quiet period as the plates move away. But gravity is relentless. It eventually slows down the drift and pulls the plates back together. This implies that our universe is stuck in an eternal cycle of destruction and rebirth. We are trapped inside a cosmic engine. Bang! Expansion, cooling, attraction, crash, bang. And the horror is that we don't know where we are in the cycle. We know the plates are moving. But since we can't see the bulk, we can't see the other plate coming. The sky could be falling right now. The next collision could happen in 1 billion years, or it could happen tomorrow. We are living on a ceiling that is destined to collapse. But if the physical universe is this hostile, a place of crashing walls and dead time, is there any part of reality that is safe? Is there a layer underneath the brains, underneath the strings, that doesn't change? This leads us to the final, deepest layer of the rabbit hole. The idea that reality isn't made of stuff at all. We have talked about colliding universes, time loops, and cosmic predators. But all these theories share one assumption. They assume that the universe is made of stuff. We assume that at the bottom of reality, there is a solid, physical material, a Lego brick that you can touch. But if you ask a particle physicist what that brick is made of, the answer gets very uncomfortable very quickly. Look at the chair you're sitting on. You say it is made of wood. The wood is made of molecules. The molecules are made of atoms. The atoms are made of subatomic particles, like electrons and protons. But what is an electron made of? If you look at the standard model of particle physics, you won't find a tiny billiard ball. You will find a list of numbers. An electron is defined entirely by its properties. Mass 9.1 times 10 to the power of -31 kilograms. Charge -1 spin 1/2. That is it. That is the electron. It isn't a little grey sphere that has mass. It is mass. If you take away the numbers, there is nothing left. There is no substrate underneath the math holding it up. This leads to a radical conclusion championed by the cosmologist Max Tegmark. He argues that we have been looking at reality backwards. We usually think that mathematics is a tool we invented to describe the universe, like a language. We think the universe comes first, and the numbers come second. But Tegmark's mathematical universe hypothesis says the opposite. It says that the numbers come first. The universe isn't described by math. The universe is math. Think about a video game. When you play, you see a tree. The tree looks solid. It has bark, leaves, and a shadow. But if you crack open the game file, there is no tree inside. There is only code. There are only sequences of zeros and ones. The solidity of the tree is an emergent illusion created by the processing of the information. Tegmark suggests that our reality is exactly like that. The stuff we touch, the rock, the water, the skin, is just the user interface. Underneath it, there is no physical matter. There is only a complex mathematical structure that has existed eternally. We are characters living inside a giant equation. And if this is true, it removes the limit on what can exist. Because equations don't need space to exist. They just need to be consistent. If our universe is just a mathematical structure, does it make sense that it is the only one? Why would nature pick this specific set of equations with our specific gravity and our specific speed of light, and say, only this one is real? In mathematics, there is no such thing as real or fake. There is only consistent or contradictory. The number pi exists. The number 7 exists. You don't need to build a physical number 7 for it to be real. It exists as an abstract truth. This leads to the concept of the level 4 multiverse. It is the ultimate expansion of reality. It states that every mathematical structure that is logically possible also exists physically. To visualize this, imagine the Library of Babel described by the writer Jorge Luis Borges. Imagine a library that contains every book that could possibly be written. Most of the books are nonsense, just random letters. But somewhere in that library is a book that tells the true story of your life. Somewhere else is a book that tells the story of your life if you had been born in Paris. Somewhere else is a book where you are a king, or a beggar, or a creature made of gas. Tegmark's multiverse is the physical version of that library. If you can write a set of physics equations that don't contradict themselves, that universe exists. It is out there. This means that fiction is a lie. There is no such thing as fiction. Every world you can imagine, as long as it obeys logic, is real. There is a universe with 6 dimensions of space. There is a universe where time flows in a circle. There is a universe that consists entirely of a single, infinite cube of gold. We are just living in one specific book in the library. We are exploring one specific set of parameters that allows for stable atoms and biological life. But we are surrounded by an ocean of alternative realities that are just as real as ours. They are not potential worlds, they are actual. This destroys the question of why. Why is the proton this heavy? Why is the sky blue? There is no why. We are just observing the local rules of our neighborhood. But if every possible version of you exists in the library, which one is the real you? And does it matter what you do if another version of you is doing the exact opposite right now? This brings us to the final existential trap. If we are just code, and if every variation of the code is running simultaneously, it feels like we are nothing. We are just data dust in an infinite machine. It feels like your choices are meaningless because the outcome is already guaranteed somewhere in the multiverse. But there is a twist in the logic that turns this prison into a playground. Think about the video game again. The code for the game is static. It is sitting on the disk, unchanging. The code contains every possible move you can make. It contains the game over screen and the victory screen at the same time. But the code itself is dark. It doesn't feel anything. The code doesn't know it is a game. It needs something else to bring it to life. It needs a player. It needs a consciousness to process the data and turn the zeros and ones into the experience of fear or joy or triumph. This is what you are. You are not the code. You are the rendering engine. The mathematical universe is dead and silent without you. It is just a list of numbers. It takes a conscious observer, you, to look at that math and convert it into red or hot or love. You are the mechanism that turns abstract possibility into concrete reality. So, even if there are infinite universes, and even if there are infinite versions of you, this specific version, the one sitting in the chair, hearing these words right now, is unique. Because you are the only one rendering this specific slice of the library. You are the lens that brings this particular coordinate into focus. This realization is the key to escaping the nihilism. The universe needs you. Not because you are good or special, but because without you, it's just a ghost. You are the witness that makes the universe real. And this leads us to the final conclusion about how we should live in a world that is this big, this scary, and this beautiful. If we accept that the universe is fundamentally made of mathematics, and that it behaves like a processing system, we have to confront the most famous modern conspiracy theory in physics. But this isn't a theory about flat earths or lizard people. It is a statistical argument put forward by the philosopher Nick Bostrom in 2003. And to this day, nobody has been able to find a flaw in his logic. It is called the simulation trilemma. Bostrom asks us to look at the trajectory of our own computing power. 40 years ago, the most advanced video game was two white rectangles passing a dot back and forth. It was called Pong. Today, we have photorealistic virtual reality where millions of people interact in simulated worlds. If we assume that technology will keep improving, even slowly, then in a few thousand years, we will have computers capable of simulating a human brain down to the neuron. And if we have enough power, we won't just simulate one brain. We will simulate billions. We will run ancestral simulations, digital recreations of our own history to see what our ancestors did. This leads to the three possibilities of the trilemma. Option 1. Civilizations always go extinct before they reach the post-human stage of technology. They blow themselves up. Option 2. They reach that stage, but they lose interest in running simulations. They just don't care. But if option 1 is false, we survive, and option 2 is false, we stay curious. Then we are left with option 3. Advanced civilizations will run billions of simulations. Here is where the trap snaps shut. If there is one base reality and billions of simulated realities, and they are indistinguishable from the inside, what are the odds that you are in the one original biological world? The odds are 1 in billions. It is statistically insignificant. If you believe that humanity will survive the next 1,000 years, and if you believe we will keep playing video games, then you logically must believe that you are currently inside a computer. You are an NPC. The memories you have of your childhood are just backstory files uploaded to your character model to give you motivation. The laws of physics we have been discussing for the last 2 hours are just the rules of the game engine. But if we are in a simulation, who is the player? And if the code is running on a machine, what happens if the machine crashes? We see glitches in our physics, like the speed of light limit, or the pixelation of the Planck length, that look suspiciously like hardware limitations. But there is one specific glitch that suggests the game was built for a very specific purpose. To figure out what the simulation is trying to achieve, we have to look at the settings menu. In physics, these are called the fundamental constants. There are about 26 numbers that define how our universe works, and nobody knows why they have the values they do. Take the strength of gravity, for example. Compared to the other forces, gravity is incredibly weak. It is 10 to the power of 36 times weaker than electromagnetism. That is a 1 with 36 zeros. Now, Imagine we open the source code of the universe and tweak that number just a tiny bit. Imagine we made gravity a little stronger. What happens? The stars would burn through their fuel in 1,000,000 years instead of billions. They would explode before life ever had a chance to evolve. If we made gravity a little weaker, matter would never clump together. No stars, no planets, just cold gas forever. It is the same with the strong nuclear force that holds atoms together. If you change it by just 2%, hydrogen would not fuse into helium. The sun would not shine. Water would not exist. Everywhere we look, the dials of the universe are set to the exact, precise decimal point required for complex life to exist. Physicists call this the Finetuning problem. It looks like we won a cosmic lottery with odds so low that they are effectively zero. There are only two ways to explain this. The first is the multiverse idea we talked about earlier, that there are trillions of broken universes with bad settings, and we are just the survivors in the one that works. But the simulation hypothesis offers a different answer. The settings are perfect because they were chosen. If you are running a simulation to study the evolution of life, you wouldn't set the gravity to a level where stars don't form. You would tune the parameters until the system produced the result you wanted. The fact that our universe is so suspiciously perfect for biology suggests that biology is the goal of the program. We are not an accident. We are the output. The entire universe, the billions of galaxies, the black holes, the dark matter, might just be the heavy machinery required to generate the specific conditions for your consciousness to emerge. But this gives you a power that sounds almost magical. If the simulation is built for the observer, does the observer control the simulation? If this is a simulation, we need to know how it handles data. Video games use a trick called foveated rendering. To save processing power, the computer only renders the part of the world that you are looking at right now. The room behind you doesn't exist in high resolution until you turn your head. Does the universe use the same trick? In the 1930s, the physicist Eugene Wigner proposed a radical interpretation of quantum mechanics called the von Neumann-Wigner interpretation. It is often summarized as consciousness causes collapse. We know from the double-slit experiment that particles exist in a blurry wave of possibilities until they are measured. Most physicists assume that measurement just means interaction with another particle. But Wigner argued that a machine cannot collapse a wave function, because the machine is also made of quantum particles. He said that the chain of maybe only stops when it hits a conscious mind. This suggests that the universe remains in a state of fuzzy, undefined superposition, until a conscious being looks at it. The moon isn't really there when nobody's looking. It is just a probability cloud. When you turn your gaze to the sky, your mind forces the game engine to render the moon in that specific spot. This means you are not just a passive character walking around a pre-built stage. You are the rendering engine. Your attention is the beam that solidifies reality. This explains why the universe seems so empty and silent. The Grabby Aliens theory. Maybe it is empty. Maybe the distant galaxies are just low-resolution background textures that will never be fully rendered, because we will never reach them. The only things that are real are the things that are being observed by a mind right now. This puts the weight of the entire cosmos on your shoulders. It means that without you, without the observer, the simulation goes dark. It implies that you are not just living in the universe, you are the reason the universe exists. But if you are the central processor of this reality, what happens when you log off? Is death just the end of the session? Or is it a wake-up call in the room outside? If we are living in a simulation or a mathematical universe, there is one final hope we cling to. We hope that if we just study the code long enough, if we build big enough particle colliders and write enough equations, we will eventually figure it all out. We hope to find the theory of everything, the single master equation that explains the simulation from top to bottom. But in 1931, a logician named Kurt Gödel dropped a bomb on mathematics that suggests this is impossible. He proved that the code isn't just hard to read, It is fundamentally broken. His discovery is called the Incompleteness theorem. Before Gödel, mathematicians assumed that math was a perfect system. They thought that for every true statement, there was a proof to back it up. But Gödel proved mathematically that in any logical system complex enough to do basic arithmetic, there will always be statements that are true, but cannot be proven within the system. Think about what that means for physics. We are using math to describe the universe, but Gödel proved that the map can never be complete. There will always be blind spots in the laws of nature, truths that exist but have no derivation. It is like reading a book that contains a list of every book in the library. If the book lists itself, it creates a paradox. If it doesn't list itself, the list is incomplete. This implies that we can never fully understand the simulation from the inside. We are logically barred from seeing the source code. There will always be a glitch, a gap in our knowledge that no amount of science can bridge. We see hints of this already. We can't reconcile gravity with quantum mechanics. We can't explain dark energy. Maybe these aren't just hard problems. Maybe they are the Gödelian holes in the system. The universe contains bugs that are true but unprovable. So if we are trapped in a system that we can never fully understand, are we at least free to leave? Or does the logic of the multiverse create a cage that keeps us here forever? This brings us to the most terrifying personal implication of quantum mechanics. The idea that you are physically incapable of dying. We talked about the many worlds interpretation earlier. The idea that every time a quantum event happens, the universe splits. In one branch, the electron goes left. In the other, it goes right. Usually we think about this in terms of sci-fi choices. In another world, I am rich. But if you take this theory seriously, you have to apply it to the ultimate choice, life or death. Imagine a game of Russian roulette. You put one bullet in a revolver, spin the chamber, put it to your head, and pull the trigger. There is a 1 in 6 chance the gun fires. In a single universe, you have a huge risk of dying. But in the many worlds model, the firing of the gun is a quantum event. The universe splits. In one branch, the hammer hits the bullet, the gun fires, and you die. In the other 5 branches, the hammer hits an empty chamber, click, and you live. Here is the horror. You cannot experience the branch where you die. From the perspective of the dead you, the screen goes black. The narrative ends. The only consciousness that continues is the one in the surviving branches. So from your subjective perspective, you will always hear the click. You could pull the trigger 50 times. In the vast majority of universes, you are dead and your family is crying at your funeral. But in the one thin sliver of probability where the gun jams 50 times in a row, you're still there, wondering why you can't die. This is called quantum immortality. It suggests that from your own first-person perspective, you will never cease to exist. You will survive every accident. You will survive every disease. You will survive old age, perhaps hooked up to machines, or perhaps as a Boltzmann brain hallucinating in the void. You are trapped in the survivor timeline. As everyone you know dies in your reality, you keep going, pushed into increasingly improbable and lonely branches of the multiverse. You are the only observer who cannot leave the room. It turns the promise of eternal life into a threat. It means there is no exit. The game engine refuses to let the player log off because the you that logs off stops observing. But if we are forced to survive, does the universe have a plan for us? Or are we just stuck here? If we are stuck in this immortal, expanding, glitchy simulation, we have to ask, what is the point? Why does the universe have these specific rules? Why does it allow for Grabby Aliens and quantum immortality? The physicist Lee Smolin proposed a theory that ties all of this together into a grand biological purpose. He calls it cosmological natural selection. He noticed that the conditions required to create life, carbon, oxygen, long-lived stars, are strangely identical to the conditions required to create black holes. To make a black hole, you need a massive star to collapse. To make a massive star, you need heavy elements to cool the gas clouds. Smolin argues that black holes are the reproductive organs of the universe. When a singularity forms, it bounces and creates a baby universe on the other side, with slightly mutated laws of physics. This means that universes evolve. A universe that cannot make black holes is sterile. It dies without offspring. A universe that makes lots of black holes is fertile. It has trillions of children. Over eternity, the multiverse fills up with fertile universes that are optimized for black hole production. And here is where we fit in. We think we are special. We think the universe is fine-tuned for us. But Smolin suggests we are just a side effect. We are the mold growing on the reproductive machinery. The universe is optimized for making black holes. We just happen to be made of the same carbon-rich dust that the black holes need. Or it is darker than that. Maybe we are not a side effect. Maybe we are the catalyst. Think about the Grabby Aliens theory again. Advanced civilizations consume energy. They manipulate matter. Eventually, a Type 3 civilization might learn to manufacture black holes for energy storage or computation. If that is true, then intelligent life is the universe's way of building better reproductive organs. We are the cells evolved to help the cosmos clone itself more efficiently. We are not the point of the simulation. We are the workers in the factory. This explains the silence. It explains the fine-tuning. It explains the persistence of consciousness. We are kept alive, and we are pushed to expand, because the universe needs us to build the next generation of realities before this one burns out. We are the midwives of the multiverse. We established earlier that we fit the profile of the Grabby Aliens, the species that eats the galaxy. But there is a massive assumption hidden in that theory. It assumes we survive. It assumes that once a civilization learns to split the atom and build computers, it inevitably goes on to conquer the stars. But looking at the last 100 years of human history, that feels like a very dangerous bet. This brings us back to the concept of the Great Filter, but with a darker twist. What if the filter isn't behind us, evolution of life, but directly in front of us? There is a statistical principle called the Lindy effect. It says that for non-biological things, like ideas, technologies, or civilizations, their future life expectancy is proportional to their current age. The longer something has survived, the longer it is likely to survive. The pyramids have been here for 5,000 years. They will likely be here for 5,000 more. The internet has been here for 40 years. We can't be sure it will last another 40. Humanity, as a technological civilization capable of destroying itself, is very young. We have only had nuclear weapons for 80 years. We have only had synthetic biology and AI for a decade. According to the Lindy effect, we are in the infant mortality phase of civilization. The math of the Great Filter suggests that most civilizations that reach our level don't become grabby. They become dead. They discover a technology that is too powerful to control, like a self-replicating nanobot, a runaway AI, or a weaponized virus, and they accidentally sterilize their own planet before they can launch a single colony ship. This creates a terrifying possibility known as the filter of silence. Maybe the reason the universe is empty isn't just because we are the first. Maybe it's because everyone else who reached this stage pulled the trigger. If this is true, then we are walking through a minefield blindfolded. Every new discovery in physics, every breakthrough in AI, increases the probability of a game over event. We are racing against our own incompetence. And the scary part is, we don't know which technology is the mine. We just know that statistically, 100% of previous civilizations in our light cone have failed to leave a visible mark. We are trying to do something that has never been done, and the odds are stacked against the infant. But even if we survive our own technology, we have to survive the universe itself. And it turns out, the ground we are standing on might not be as solid as we think. I am talking about the stability of the vacuum itself. In physics, vacuum doesn't mean empty space. It means the lowest possible energy state of a field. Think of it like a ball sitting at the bottom of a valley. If the ball is at the very bottom, it is stable. You can kick it, and it rolls back down. This is a true vacuum. But what if the ball isn't at the bottom? What if it is stuck in a little dip halfway up the hill? It looks stable. It feels stable. But if you give it a hard enough kick, it will roll over the edge and crash down to the real bottom. This is called a false vacuum. For decades, we didn't know which kind of vacuum we lived in, but in 2012, we found the Higgs boson. The Higgs is the particle that gives everything mass, and when we measured its mass, it came out to roughly 125 gigaelectronvolts. This specific number is the worst possible news. If the mass were lower, we would be stable. If it were higher, we would be unstable, but obviously so. But at 125, we are in a metastable zone. It means we are living in a false vacuum. We are balancing on a ledge. This implies that at any moment, in any random point in the universe, a quantum fluctuation could kick the Higgs field. If that happens, a bubble of true vacuum will form. Inside this bubble, the laws of physics are different. Chemistry doesn't work. Atoms can't hold together. This bubble would expand at the speed of light. Because it moves at light speed, you would never see it coming. 1 second you are reading this text, and the next second, your atoms simply cease to exist. The bubble would consume the Earth, the Sun, and the entire galaxy, rewriting reality into a lower energy state where life is impossible. It could have happened a billion light years away 10 years ago, and the death wave is rushing toward us right now. We wouldn't know until it hit. It makes the entire universe feel like a temporary glitch that could be patched out at any second. If the physical world is fragile, let's go back to the question of control. We talked about retrocausality denying free will, but there is an even darker theory called superdeterminism that suggests the entire universe is a rigged game. It starts with something called Bell's theorem. John Bell came up with a test to see if quantum particles truly have hidden variables or if they are truly random. The experiments show they are random or communicate faster than light. But Bell made one small assumption in his math. He assumed statistical independence. He assumed that the scientist is free to choose which setting to measure on the machine. He assumed that the atoms in the scientist's brain are not conspiring with the atoms in the particle detector. Superdeterminism asks, what if they are conspiring? What if the Big Bang set up the initial conditions of the universe so precisely that every random choice you make is actually pre-correlated with the result you are going to get? Imagine a magician who asks you to pick a card. You think you have a free choice, but the magician arranged the deck, the lighting, and your angle of vision so that you had to pick the ace of spades. You felt free, but the outcome was forced. Superdeterminism suggests the universe is that magician. It implies that there is no randomness in quantum mechanics. The reason we see weird patterns is that the universe is plotting against us. The atoms in your brain that decide to measure spin up were correlated with the atoms in the electron that decided to be spin up 13 billion years ago. If this is true, then science is fundamentally impossible. Science relies on the idea that we can do independent tests. But if the test subject and the tester are both puppets dancing to the same pre-written script, then we aren't discovering the laws of nature. We are just watching a movie and thinking we are directing it. It is the ultimate paranoia. It means that logic itself is a trick. The universe isn't just watching you, it is controlling your attempt to understand it. So, we are trapped in a rigged, fragile, dangerous simulation. Why? Is it just a torture chamber? Or is the script heading somewhere? There is a theory, originally proposed by the philosopher Pierre Teilhard de Chardin and later digitized by physicist Frank Tipler, called the omega point. It suggests that the universe is not a machine that is running down. It is a machine that is booting up. Look at the trend of information. At the Big Bang, the universe was simple. Then it made atoms, then stars, then biology, then brains, then computers, then the internet. At every step, the density of information processing increases. The theory argues that this isn't an accident. The The universe is driven by a compulsion to organize itself. We are currently in the early stages of the noosphere, a planetary layer of thinking matter. But the trend points forward. Eventually matter will be converted into computronium, matter optimized for calculation. The Grabby Aliens we feared, they are just the next step in the boot process. They are converting dumb rocks into smart processors. The goal of the universe is to reach the omega point, a state where every atom in the cosmos is part of a single, infinite computer. When that happens, the universe wakes up. It becomes a god mind capable of processing infinite information. In this view, we are not insignificant. We are the neurons of the baby god. Our struggles, our wars, our internet memes, they are the synaptic firings of a mind that is trying to open its eyes. And here's the twist. If the omega point has infinite processing power, it can simulate every possible past. It can resurrect everyone who ever lived inside its memory. So, we are back to the simulation. Maybe we are already in the omega point's memory. Maybe the universe has already woken up, and we are just reliving the dream of its birth. This leads us to the final logical trap, the one you can't escape. If the universe is a single mind, cosmopsychism, or a single computer, simulation, or a single block of time, retrocausality, then how many people are actually here? Count them. If I am a dissociation of the one mind, and you are a dissociation of the one mind, then I am talking to myself. Solipsism is usually treated as a joke in philosophy. I am the only thing that exists. It sounds arrogant, but if you follow the physics of the one electron universe or the single wave function, it becomes a heavy scientific hypothesis. There is only one player. You look at your friends, your parents, your enemies, they seem separate, but that is just the graphics engine. Underneath the skin, it is the same consciousness looking out of billions of different pairs of eyes. The universe is a hall of mirrors. You are terrified of the Grabby Aliens, but the aliens are just you in a different spaceship. You are terrified of the heat death, but the heat death is just you going to sleep. This creates a feeling of profound, cosmic loneliness. If you are God, then you are alone. You created this entire drama, the pain, the joy, the wars, the physics, just to distract yourself from the infinite silence of being the only one. You fractured yourself because unity was too boring. You accepted the risk of suffering because the alternative was eternal nothingness. So, when you look in the mirror, you aren't looking at a human. You're looking at the universe wearing a mask, pretending it doesn't know who it is, just to feel the thrill of discovery for a little while longer. So, here is the situation. Physics tells us we are fleeting glitches in a dying universe. We are likely simulated, probably determined by the future, and surrounded by a silent, hostile void. Logically, the correct response to this information is to lie down and stop moving. If the outcome is heat death or erasure, why bother getting out of bed? Why bother building a house, falling in love, or recording a video? This is where the friction starts. Your logical brain sees the futility, but your biological brain refuses to accept it. You feel a drive, you feel hunger, you feel ambition, you feel the need to be happy. This is the cruelty of evolution. We are biological machines programmed by natural selection to survive and reproduce. To make us do that, evolution coded a set of illusions into our software. It gave us the illusion of purpose. It gave us the chemical spikes of dopamine and serotonin to reward us for finding patterns and solving problems. We are built to hunt for meaning the way a shark is built to hunt for blood. We can't turn it off. We look at the stars and our brain screams, "There must be a reason." We look at our lives and scream, "There must be a story." But the universe is not biological. It is mathematical. It doesn't run on dopamine. It runs on entropy. It doesn't care about stories. It cares about equilibrium. So we are trapped in a crossfire between our hardware, biology, and our environment, physics. We are meaning-seeking missiles launched into a meaningless void. The pain you feel when you think about these theories, the existential dread, is just the friction of your programming grinding against reality. You're trying to run a hope algorithm on an operating system that was designed for decay. This creates the ultimate paradox of the human condition. We are smart enough to realize the cage exists, but we are too biological to stop rattling the bars. We are cursed with just enough intelligence to see the emptiness, but not enough to transcend it. Is there a way to break this deadlock without going insane? The philosopher Albert Camus called this conflict the absurd. He pictured humanity as a man standing in front of a giant silent mountain, screaming, "What is the meaning of this?" And the mountain just sits there, being a mountain. The absurd isn't the fact that the universe has no meaning. The absurd is the fact that we keep asking. If you look at the Grabby Aliens theory or the heat death, the universe is clearly indifferent. It is not evil. Evil implies intent. The universe is worse than evil. It is uncaring. It would crush us with a vacuum bubble or wipe us out with a gamma ray burst without even noticing. The same way you don't notice the bacteria you kill when you wash your hands. Most people try to solve this by lying. They invent stories. They say, the universe is testing us, or the aliens are watching us. We project human emotions onto the gravity and the gas because the alternative, absolute indifference, is too cold to handle. But if we want to be honest, if we want to play by the rules of the physics we have discussed for the last 3 hours, we have to stop lying. We have to look the indifference in the eye. The universe is a machine for making black holes. It is a computer processing data. It is a foam of colliding brains. It does not know your name. It does not care if you are a good person. It does not care if your civilization lasts 10 years or 10 billion years. That sounds depressing. It feels like we are orphans. But if you flip the logic, this absolute lack of care becomes the most liberating force in existence. Because if the universe doesn't care, it means the universe isn't watching. And if it isn't watching, it isn't judging. Think about what it would mean if the universe did have a meaning. Imagine if there was a visible, objective purpose written in the stars. Suppose we found a message encoded in the cosmic microwave background that said, "Humanity exists to mine gold for the galactic empire." That would be a purpose, that would be a meaning, but it would be a prison. It would mean you are a slave to a script you didn't write. You would be failing if you didn't mine gold. You would be wrong if you wanted to paint instead. The fact that the universe has no inherent meaning is the only thing that guarantees your freedom. Nihilism, the belief that nothing matters, is usually seen as a dark hole. But optimistic nihilism turns the hole into a canvas. If the universe didn't give you a purpose, that means you hold the pen. You are the only entity in your immediate volume of space-time capable of generating meaning. If you decide that the point of your life is to play video games, raise a family, or solve the Riemann hypothesis, the universe cannot contradict you. It has no opinion. Gravity won't object. Entropy won't argue. You become the local god of significance. In a universe of dead rocks and cold gas, the only place where good, evil, love, or value exists is inside your own head. You are the generator. This solves the biological trap. We don't have to find the meaning out there in the silence. We have to project the meaning from here into the silence. We are not discovering the script, we are writing it on top of the static. The Grabby Aliens consume matter. We consume the void and fill it with context. Let's go back to the mathematical universe. We said that at the bottom, reality is just numbers. Mass is a number. Spin is a number. Wavelength is a number. But numbers are dark. The equation for red light, wavelength roughly 700 nanometers, is not red. It's just math. The equation for sugar is not sweet. It's just geometry. The universe, on its own, is a silent, colorless, tasteless scaffold of logic. It creates the potential for experience, but it cannot experience itself. This is where you come in. You are the rendering engine. Your brain is the machine that takes the abstract data of the cosmos and converts it into qualia, the feeling of being alive. You are the only mechanism that turns the math into the movie. Without you, and observers like you, the universe is just a dark hard drive spinning in a void. It contains the code for a sunset, but nobody sees it. It contains the code for pain, but nobody feels it. You are performing a service for reality. You are witnessing it. This connects back to the cosmopsychism theory. If the universe dissociated to experience itself, then you are the sensory organ of God. You are the eyes of the system. Even if you are just a Boltzmann brain hallucinating for a second, in that second, you turn the lights on. This gives you a cosmic job description. Your job isn't to be successful or famous or rich. Those are human games. Your job physically is to perceive. Your job is to be the lens that brings the fuzzy quantum probability into sharp focus. As long as you are conscious, you are fulfilling the only purpose the universe could possibly have, to be known. But what about the end? We still have to deal with the heat death and the erasure of time. It feels like no matter what we do, no matter how much we perceive or create, it all gets washed away eventually. This is where the block universe theory stops being a trap and starts being a sanctuary. Remember, in the block universe and retrocausality, time is a solid crystal. Past, present, and future exist simultaneously. We feel like we are moving through it, but the structure itself is static. This means that erasure is impossible. When a song finishes playing on a vinyl record, the notes don't disappear from the plastic. The needle just moves past them. The song is still there, physically etched into the groove. Your life is a four-dimensional groove carved into the block of space-time. It has a start coordinate and an end coordinate, but the carving itself is permanent. Every moment you experience, right now looking at this screen, is a real, physical structure in the eternal architecture of the multiverse. Even 1 trillion years from now, when the stars are dead and the entropy is maxed out, the you of the 21st century is still frozen in the crystal, laughing, crying, and thinking. The universe doesn't delete its history, it just stops adding to it. We have spent 4 hours talking about how the universe is terrifying. We talked about the monsters in the dark, the heat death, and the simulation traps. But there is one final piece of math that flips the table on all of it. It is the calculation of your own existence. Think back to the Boltzmann Brain theory. We established that in an infinite, chaotic universe, it is vastly easier for random atoms to assemble into a fake brain for 1 second than it is to evolve a real biological human over billions of years. The odds favor the fake brain by a margin of 10 to the power of 50. Now, add the Grabby Aliens odds. It is statistically unlikely for a civilization to arise this early in the cosmic morning. Now, add the fine-tuning odds. The constants of physics had to be perfect to within 1/1,000,000,000% to allow atoms to hold together. If you multiply all these probabilities together, the chance of you existing, right here, right now, in a biological body, on a stable planet, in a stable vacuum, is effectively 0. The calculator just says, error. By all the laws of physics and probability, you should not be here. You should be a cloud of gas. You should be a Boltzmann hallucination. You should be dead dust in a sterile universe. But you aren't. You are breathing. You are processing information. You are defying the entropy of the universe just by sitting in that chair. This means you are the biggest statistical anomaly in the cosmos. You are a glitch in the thermodynamics. The fact that you exist is the most impossible thing that has ever happened. So, when you feel small looking at the stars, remember that the stars are easy. Burning hydrogen is simple. Being a conscious observer in a chaotic void is the hardest trick in the book. You have already won the ultimate lottery. The question is, what are you going to do with the winnings? To understand the value of that winnings, you have to realize what you are made of. We often say, I am in the universe, like you're a visitor walking through a museum. But that linguistic distinction is a lie. The astrophysicist Neil deGrasse Tyson, following Carl Sagan, reminds us of the literal biological connection. Look at your hand. The carbon in your skin, the iron in your blood, the calcium in your bones. Where did it come from? At the Big Bang, the universe only made hydrogen and helium. It didn't make carbon. It didn't make the stuff of life. To make the atoms that allow you to think, the universe had to build massive stars. It had to cook those elements in nuclear furnaces for millions of years. And then, it had to blow those stars up. Every atom in your body was forged in the catastrophic death of a star that exploded billions of years before the Earth was formed. You are made of nuclear waste. You are the recycled debris of a supernova. This means you are not separate from the violent history of the cosmos. You are the direct result of it. You are the universe organizing itself into a shape that can look back at itself. When you look at the night sky, you aren't looking at external objects. You're looking at your ancestors. The galaxy is your body. The gravity is your skin. The separation you feel is just a trick of the mind. The cosmopsychism dissociation. Underneath the illusion, you are the mechanism itself waking up. So you don't have to be afraid of the universe. That would be like your hand being afraid of your arm. You are the universe. And that gives you the authority to decide what it means. If you are the universe waking up, and if the Grabby Aliens theory is true, then you have a job to do. Remember, the theory says we are the firstborn. The galaxy is empty. The silence is waiting for us. This isn't a license to be arrogant. It is a burden of responsibility. If we are the first, that means there is nobody coming to save us. There are no wise elders to stop us from blowing ourselves up. There is no safety net. If humanity fails, if we destroy ourselves with nuclear war, or AI, or engineered viruses, we don't just kill ourselves. We might be killing the only chance for consciousness in this entire sector of the universe. If we are the nucleation point for life in the Milky Way, then the future of trillions of stars depends on whether we survive the next 100 years. We are holding the torch in a very dark room. If we drop it, the lights go out for eons. This changes the way you look at the news. It changes the way you look at politics. These aren't just squabbles on a rock. They are the growing pains of a baby god trying to learn how to walk before it falls off a cliff. We are the great filter. We are the ones who decide if the galaxy stays dead or becomes a garden. The silence of the night sky isn't empty. It is an awaiting canvas. And we are the only ones holding the brush. But how do we paint on that canvas if the second law of thermodynamics is trying to erase us? We talked about heat death. We talked about how the universe wants chaos. It wants to pull your house down. It wants to rot your body. It wants to scatter your memories. The universe is a machine for destroying information. But life is the opposite. Life is a machine for creating information. Every time you learn a fact, every time you build a tool, every time you create a piece of art, you are spitting in the face of entropy. You are creating a local pocket of order in a universe of disorder. This makes your life a rebellion. Simply being alive is an act of defiance against the laws of physics. When you clean your room, you are fighting the heat death. When you raise a child, you are fighting the void. When you preserve a memory, you are fighting the erasure of time. Sure, in the long run, entropy wins. The sandcastle eventually falls, but the victory isn't in staying standing forever. The victory is in standing up at all. The fact that we can build structure in a chaotic world, even for a brief moment, is the wildest magic trick in existence. We are the resistance movement against the decay, and every moment of joy you snatch from the jaws of the nothingness is a battle won. And what happens to that joy when you are gone? Does it vanish? Not if you believe in the physics of waves. Recall the Wheeler-Feynman absorber theory. Every particle sends a wave into the future. Every action you take broadcasts a signal that travels at the speed of light, rippling out into the cosmos forever. Your life is not a closed loop. It is a transmission. The light bouncing off your face right now will travel past the moon, past Mars, and out of the galaxy. 1 billion years from now, those photons will still be traveling through the vacuum. The gravitational waves from your movements will still be shifting the fabric of space-time, however slightly. You're changing the structure of the future just by being in it. In a block universe, your world line, the path you took through time, is a permanent fixture. You are knitting a thread into the blanket of reality. The universe is different because you were here, maybe only slightly different, but in a chaotic system, the butterfly effect, slight differences amplify over time. A decision you make today could be the boundary condition that determines the state of a solar system 1 million years from now. We don't know the impact of our signal. We just know that we are broadcasting. And if we are the firstborn, our signal is the first one to ring out in the silence. So, make it a good one. Make it a signal worth receiving. We have spent 4 hours talking about how the universe is terrifying. We talked about the monsters in the dark, the heat death, and the simulation traps. But there is one final piece of math that flips the table on all of it. It is the calculation of your own existence. Think back to the Boltzmann Brain theory. We established that in an infinite, chaotic universe, it is vastly easier for random atoms to assemble into a fake brain for 1 second than it is to evolve a real biological human over billions of years. The odds favor the fake brain by a margin of 10 to the power of 50. Now add the Grabby Aliens odds. It is statistically unlikely for a civilization to arise this early in the cosmic morning. Now add the fine-tuning odds. The constants of physics had to be perfect to within 1/1,000,000,000th of a percent to allow atoms to hold together. If you multiply all these probabilities together, the chance of you existing right here, right now, in a biological body, on a stable planet, in a stable vacuum, is effectively 0. The calculator just says, error. By all the laws of physics and probability, you should not be here. You should be a cloud of gas. You should be a Boltzmann hallucination. You should be dead dust in a sterile universe. But you aren't. You are breathing. You are processing information. You are defying the entropy of the universe just by sitting in that chair. This means you are the biggest statistical anomaly in the cosmos. You are a glitch in the thermodynamics. The fact that you exist is the most impossible thing that has ever happened. So when you feel small looking at the stars, remember that the stars are easy. Burning hydrogen is simple. Being a conscious observer in a chaotic void is the hardest trick in the book. You have already won the ultimate lottery. The question is, what are you going to do with the winnings? To understand the value of that winnings, you have to realize what you are made of. We often say, I am in the universe, like you're a visitor walking through a museum. But that linguistic distinction is a lie. The astrophysicist Neil deGrasse Tyson, following Carl Sagan, reminds us of the literal biological connection. Look at your hand, the carbon in your skin, the iron in your blood, the calcium in your bones. Where did it come from? At the Big Bang, the universe only made hydrogen and helium. It didn't make carbon. It didn't make the stuff of life. To make the atoms that allow you to think, the universe had to build massive stars. It had to cook those elements in nuclear furnaces for millions of years. And then, it had to blow those stars up. Every atom in your body was forged in the catastrophic death of a star that exploded billions of years before the Earth was formed. You are made of nuclear waste. You are the recycled debris of a supernova. This means you are not separate from the violent history of the cosmos. You are the direct result of it. You are the universe organizing itself into a shape that can look back at itself. When you look at the night sky, you aren't looking at external objects. You are looking at your ancestors. The galaxy is your body. The gravity is your skin. The separation you feel is just a trick of the mind, the cosmopsychism dissociation. Underneath the illusion, you are the mechanism itself waking up. So you don't have to be afraid of the universe. That would be like your hand being afraid of your arm. You are the universe, and that gives you the authority to decide what it means. If you are the universe waking up, and if the Grabby Aliens theory is true, then you have a job to do. Remember, the theory says, we are the firstborn. The galaxy is empty. The silence is waiting for us. This isn't a license to be arrogant, it is a burden of responsibility. If we are the first, that means there is nobody coming to save us. There are no wise elders to stop us from blowing ourselves up. There is no safety net. If humanity fails, if we destroy ourselves with nuclear war, or AI, or engineered viruses, we don't just kill ourselves. We might be killing the only chance for consciousness in this entire sector of the universe. If we are the nucleation point for life in the Milky Way, then the future of trillions of stars depends on whether we survive the next 100 years. We are holding the torch in a very dark room. If we drop it, the lights go out for eons. This changes the way you look at the news. It changes the way you look at politics. These aren't just squabbles on a rock. They are the growing pains of a baby god trying to learn how to walk before it falls off a cliff. We are the great filter. We are the ones who decide if the galaxy stays dead or becomes a garden. The silence of the night sky isn't empty, it is an awaiting canvas, and we are the only ones holding the brush. But how do we paint on that canvas if the second law of thermodynamics is trying to erase us? We talked about heat death. We talked about how the universe wants chaos. It wants to pull your house down. It wants to rot your body. It wants to scatter your memories. The universe is a machine for destroying information. But life is the opposite. Life is a machine for creating information. Every time you learn a fact, every time you build a tool, every time you create a piece of art, you are spitting in the face of entropy. You are creating a local pocket of order in a universe of disorder. This makes your life a rebellion. Simply being alive is an act of defiance against the laws of physics. When you clean your room, you are fighting the heat death. When you raise a child, you are fighting the void. When you preserve a memory, you are fighting the erasure of time. Sure, in the long run, entropy wins. The sandcastle eventually falls, but the victory isn't in staying standing forever. The victory is in standing up at all. The fact that we can build structure in a chaotic world, even for a brief moment, is the wildest magic trick in existence. We are the resistance movement against the decay, and every moment of joy you snatch from the jaws of the nothingness is a battle won. And what happens to that joy when you are gone? Does it vanish? Not if you believe in the physics of waves. Recall the Wheeler-Feynman absorber theory. Every particle sends a wave into the future. Every action you take broadcasts a signal that travels at the speed of light, rippling out into the cosmos forever. Your life is not a closed loop. It is a transmission. The light bouncing off your face right now will travel past the moon, past Mars, and out of the galaxy. 1 billion years from now, those photons will still be traveling through the vacuum. The gravitational waves from your movements will still be shifting the fabric of space-time, however slightly. You're changing the structure of the future just by being in it. In a block universe, your world line, the path you took through time, is a permanent fixture. You are knitting a thread into the blanket of reality. The universe is different because you were here, maybe only slightly different. But in a chaotic system, the butterfly effect, slight differences amplify over time. A decision you make today could be the boundary condition that determines the state of a solar system 1 million years from now. We don't know the impact of our signal, we just know that we are broadcasting. And if we are the firstborn, our signal is the first one to ring out in the silence. So, make it a good one. Make it a signal worth receiving. We have spent the last few hours tearing reality apart. We looked into the silence and found that we are the monsters. We looked at our minds and found a cosmic illness. We looked at time and found a prison. We looked at the ground beneath our feet and found a simulation running on a dying battery. It is enough to make you want to curl up and hide. But the only reason these theories scare you is that you are making one fundamental error. You are still thinking of yourself as a victim of the universe. You are seeing yourself as a tiny, fragile thing trapped inside a giant, hostile machine. But physics tells us that there is no inside and outside. There is no boundary where you end and the universe begins. You are not in the simulation, you are the rendering engine that makes it real. You are not trapped in the block universe, you are the geometry that defines it. You are not afraid of the Grabby Aliens, you are the Grabby Aliens. The atoms in your hand are the same age as the universe. The electricity in your brain is the same force that lights up the thunderstorms on Jupiter. You are not a stranger here. You are the mechanism itself. You are the galaxy waking up, looking in a mirror, and frightening itself with its own reflection. So, when you feel the weight of the heat death or the vertigo of the multiverse, do not turn away. Embrace it. That weight is just the feeling of your own scale. You are the only thing in the darkness that can feel, think, and create. You are the part of the universe that learned to tell a story. The void is silent. The math is cold. The future is uncertain. But you are here. You are the glitch that defies the entropy. And as long as you are watching, the lights stay on. So, here is my final advice to you. Do not let these theories paralyze you. Let them liberate you. If nothing matters in the long run, then you are free to decide what matters right now. If the universe is a blank canvas, then throw your paint at it as hard as you can. Live a life that is worth recording in the block universe. Build something that screams against the silence. Be the grabby force that fills your corner of the cosmos with noise, art, and memory. We are walking a tightrope over a bottomless pit, but the view is spectacular. So keep looking up. Keep asking the terrifying questions. And remember, you are the statistical miracle that made it to the party. Enjoy it while it lasts. If you made it this far into the deep end, you are exactly the kind of person who belongs here. If this journey shifted your perspective on reality, hit the like button. It helps the signal reach other observers in the algorithm. I want to know what you think. Which theory keeps you up at night? Are we the firstborn monsters? Or are we just brains floating in a void? Leave your verdict in the comments below. I read them to remind myself I'm not the only one staring at the ceiling. And if you want to peel back more layers of the universe with me, make sure to subscribe and ring the bell. We have a lot more blueprints to examine. Thank you for watching. With you was Acronium.